I don't have to tell you that 4K UHD and the transition to IP are the trending topics in our industry, and I'm curious to hear the panelists' thoughts on the actual status and their vision for the future. Let me introduce the participants. On the stage we have Mr. Phil Myers, IP Product Manager, Snell Advanced Media, Thierry Pauls, Senior Product Manager, EVS, Simon Reed, Managing Director, Evertz UK, and Mr. Thomas Riedel, CEO, Riedel Communications. This session will be moderated by David Davies, Managing Editor, SVG Europe. So the stage is yours.
Thank you very much. Thank you. We've only got about sort of 25, 30 minutes at most, so we'll just try and get through as many of the key aspects as possible. But I thought we'd begin by just sort of having a bit of a progress report. In terms of this overall transition to 4K production, how far do you think we've advanced at this time? And how much further have we got to go? Just opening thoughts from you, Phil.
So I think we're still in the ascent. We're still in the early stages of 4K being deployed. There's multiple ways to deploy 4K. So some companies are choosing to go SDI. Some companies are choosing to go IP for a number of reasons. There's still a number of different types of connectivity, so quad link, whether it's 2SI, square division, 12 gig. And then when we get into the IP domain, actually we start going into the kind of network bandwidth speeds, whether we need compression or not. So I think if companies today looking to build brand new OB trucks and studios and flyaways, they're always now looking to build it with 4K in mind. In terms of actual 4K production, we're seeing that the early adopters of 4K is predominantly in the large sporting brands. So when you look at things like Premiership Football, Formula One, these are all the early adopters moving to a UHD production. But we will see this move over time as it kind of the technology becomes a little bit more mature. Customers have a better understanding of what they want to do, whether it's SDI or IP, and where they want to get to.
Obviously, particularly in the sports world, we're seeing a lot of sports move into 4K production. Formula One obviously has just started doing that with Sky. Thomas, do you agree with that sort of summary that Phil's just offered in terms of the overall state of where we are at the moment?
Well, I agree. In general, we see that it is very different depending on the where you look in the industry. It's different in the industries, but also on the geographical scale, you can see it's more there or not. Looking at the technologies, there is not one clear direction. I mean, the early adopters logically use the 3G SDI connections, and that's something we've done in a number of projects, and it works pretty well. But we can't see a clear direction whether people really want to go the 12G SDI or IP. So we don't like that really, because as a manufacturer you would love to see one thing, and I guess most of you guys would want to have kind of one standard. But I think it's really the unfortunate way that both potential technologies will see its place in the industry, and therefore we have to support both, and we will.
Simon, obviously there are, as Thomas has been saying, lots of different ways of going about 4K production, different formats. Can you talk us through the sort of the primary ones and the primary benefits of each one?
Yes, I mean at the moment the problem really is too much choice in how to implement 4K. So we've got a lot of existing customers doing 4 lanes of 3G. That's the obvious way of doing it, the SQD format, square division format. We've got customers in Korea who are moving over to 12 gig SDI, but that is naturally using this 2SI, two sample interleave method. So we then find they're implementing also 4 lanes of 2SI, and then you move everything else into the IP domain. That's yet another variable, and then we throw into that mix HDR and all the color space correction problems. And really we've got way too many ways of implementing the same thing at the moment. And cross-converting between them can be quite tricky. For instance, to go from SQD to 2SI is a frame of delay, not something you'd want in a live sports environment. So,
as you say, there are lots of different options there, but what are the kind of elements that are going to determine which ones are eventually selected, which formats the industry coalesces around, if you like?
There's no clear direction at the moment. It's a very confusing picture.
Yeah.
We've got customers trying to implement 12 gig SDI, But they've actually chosen, in certain cases, to implement both the 2SI format and the SQD format and run them in parallel for the simple reason they don't know which one is going to win out, and they don't know which one technically is going to give the best results.
Obviously, this has huge implications for cost and extent of R&D, and as you say, manufacturers having to accommodate these different options. Thierry, can you sort of talk about the implications of that from an EVS perspective?
Yeah, it's about, as everybody was saying, it's so many formats, so many ways of doing that 4K things, and all the constraints that it's not easy to move from one way of doing it to another, because then you have to deal with all the other equipments in the chain. Sometimes you start doing 4K, but you still have legacy equipments that only support one of those formats, and everybody, for instance, is asking for 2SI, but then one says, oh, by the way, I don't support it, so can you please do the other one? And at the end, you have to do everything. So it's really tricky. And as you mentioned, looking to the future, there's no clear picture. And even if everybody thinks IP on the long term, you have to build trucks today, you have to do productions today. Not clear. And the longer term picture is not clear either. Is that going to be 10 gig, 25 gig, uncompressed, compressed? Even if you go to the IP way, you have so many standards and so many ways of doing it. So yeah, a lot of standards to support, a lot of formats, also following the history of the thing, and it has moved so fast that for the time being, you have to do it all. So, yeah.
Well, I have a guess in this, because even so, I agree that it will not be clear for a period of time. I have a guess on what will not make the race, and that's basically, I don't think it will be a compression solution. Because on one hand, I clearly see that more and more bandwidth is available, because in all the whatever networks we talk about, the technology allow you more throughput. Also, in talking about compression comes at a price, because compression needs processing power, and there's heavy processing power needed, and you need that in all these devices. And we feel that, therefore, compression will not make the race. We're talking about raw signals. Whether this is then on an SDI and on a quad link, or on 12G-SDI or IP, it doesn't matter, because then I also say that the conversion is much easier, and also keeping things compatible. So that is at least something where we can more and more see a direction that these future solutions will not be compressed solutions.
Yeah. I agree in part of what you're saying, as you have more and more bandwidth, but on the other hand, you want to do more and more with it. And which one is the fastest? Is that the will of you guys doing the production and asking to do like not only one stream on one cable, but 5, 10, 20 streams on that single cable? Is that going to win the race against the bandwidth that you have available? You know, if you have 100 gig, but you want to bring 8 4K streams, that's going to be okay. If you want to bring 20 streams on that one, it's not going to fit. So it's really a race between bandwidth and...
I think that depends on the use case. So if you're doing remote production, then there's a use case for compression. But I agree with Thomas, that there's not just the cost of deploying encoding and decoding and processing around the system, but it's also managing the variable latencies to the system. Because every time we come in and out of a compression, you've got to worry about the system timing. Yeah. So we see actually and this also...
Quality as well, with all the compression, decompression cycles. And also interoperability, that's what we see today. If you want to do anything over IP that works between vendors, you have to go uncompressed. That's the only thing that everybody understands. Yeah,
but just going back to your point, Dave, I think when you're choosing what technology you're going to go for, normally customers will look at what devices are going to have in their environment. So in this case, it normally drives you to a quad 2SI or a quad square division, depending on whether all the devices in the chain support this. And then again, this is when we get into IP domain, there are certain scenarios where you have to be 2SI in order to get into some of the compression systems to be able to do things like remote production or contribution links.
With regard to the OB community, I think it's fair to say that the new trucks being built at the moment seem to be fairly evenly split between people going IP and people going SDI or going for a hybrid approach. What kind of timeline do you think we're looking at where people are, universally feeling confident about going for an IP-based infrastructure in an outside broadcast truck? Simon?
I think one of the things that holds back OB companies going to IP is the skill base they have within their engineering teams. When an OB arrives on site, as we all know, the engineers are totally responsible for getting that truck up and running and delivering a program. And at the moment, I see a big skill shortage in the industry in the broadcast engineering staff not being able to support IP infrastructure well enough. It's quite a different way of operating. You can no longer simply unplug an SDI coax cable and check what's on the end of it. You may have 6 or more videos coming down that cable. So it's a very different set of skills, I think, to manage an IP network.
And as a vendor, are you sort of actively supporting those kind of internal educational efforts within broadcasters so that they do have the necessary upskilling?
We haven't done to date. We've tended to find the people who want to go IP are driven to go IP, and they have the skill sets they need. I think the difficulty is going to be bringing some of the more traditional engineering staff, people who maybe have been in the industry for a long time, doing it in a very traditional way, convincing those guys to relearn their skills is going to be a challenge.
Can I throw that open to the other panelists? I mean, are your companies also actively involved in helping to sort of fill in some of those knowledge gaps?
I think it's an industry-wide thing. So I think, we also need to make sure we train our own people that are working inside the engineering, the support, the service, that they understand the technology in order to be able to create the technology, deploy it, support our customers. We have a responsibility to make sure we inform our customers of the technology, why to use the right technology, how it should be configured, and actually go with the monitoring solution. Actually, in the IP domain, there's a far greater set of tool sets that are available to monitor a lot of this technology, but it does require a certain level of retraining. But you still need to have the basic understanding of how broadcast infrastructure works in terms of the timing and the signal types that are being moved around it.
Obviously, we've seen 4K sort of establish a presence in sports quite quickly, and obviously, it's ideal for the kind of drama and high production levels of sports broadcasting. Do you think it will translate to other areas of broadcasting? Do you think we'll see it for live entertainment, music, performances, and so on? Where do you think are the other areas where it will be particularly keenly adopted?
I think from my side, it really boils down to the transmission chain and getting it to the viewer. Yeah. And I think today sports is a great way of monetizing 4K. I think the live entertainment will come, but then you look at the other kind of 4K content that's available. It tends to be packaged media, so films, and it really is going to, where you'll see it move into other genres is when there's more routes to the home, and whether it's terrestrial, whether it's satellite, or whether it's through cable or through the internet, this will drive that demand for other types of genre, I think.
Obviously, later this year, hopefully, we will see the publication of SMPTE ST2110. Do you think that will have a galvanizing impact on what we're talking about here?
Definitely. It's very good. I'm very happy to see that happen. And actually, I did not really expect it to be that soon. So I think it's really good news when you look at where we were like 2 years ago, 3 years ago. It seemed to be such a long road for having an industry-wide agreement on how to do that over IP. So, yeah, it's really good news to have that work done and everybody agree there.
Do you share that opinion, or?
Yeah, absolutely. I mean, we build things on standard, and we do this for almost 30 years now. And from that point of view, it's really important that the standards come together, and that's what's really missing currently. And with SMPTE 2110, we really expect that this is a standard, and we're looking forward to nail this down, because currently there's too many solutions out there which are all somehow IP but not compatible, and they are even more expensive than traditional solutions, and that is kind of bizarre, because the major driver in the whole process should be cost. Since basically if you look from the top down, there's not the same money coming into the industry, so it's shrinking. From that point of view, cost will be the major driver, which, by the way, also answers the other question about the labor. If an engineer, a traditional engineer, costs you like €500, dollar, whatever, a day, then an IT expert will cost you like 1,000. And logically, this will not happen. So that clearly tells that either someone invents the right IP solution, which is an easy plug-and-play solution, or that technology will definitely finally not make the race. I personally believe it will make the race. It will be IP. There's no doubt in my mind. There's no doubt about that. But the winner in basically the competition on the manufacturer side will be the companies which will master the complexity in a way that it will be a plug-and-play for the engineers. So today's engineers will manage these future systems, even so they're not IP experts. And this needs to be basically the goal. So that's where we need to look at companies which really have that in mind.
I'd like to give you all the opportunity just to talk briefly about your latest solutions that support 4K production. Can I begin with you, Thierry?
Yeah, so I mean, it's really what Thomas was saying, that the goal is to make, actually just change the transport layer and make it happen as it was SDI, whether that is SDI, IP doesn't really matter to the guys operating the trucks and making the production. So down the line, it just has to behave in the same way, and definitely working into making that possible, whether that is on the installation and setting up the workflow, or the truck when you're in a OB production, and that's providing the tools for the monitoring and the operation, so that it's really transparent and doesn't at the end change the way you work, because as we've done from SD to HD, then from HD to 4K, or moving to IP, your job is bringing the picture to the viewer, whatever the technology is in there. So it's definitely.
I was talking more in terms of your specific solutions at EVS. What's your latest solution in terms of offering 4K support? This would be the XT.
Yeah, so we have the XT4K in terms of production, but yeah, I was talking about, I think the bottom line of moving to the IP and 4K thing together is also building that tools for handling the production and the stream. So that's really something we're working on at the moment, that we were showing at NAB, we'll show again at IBC, on how to deal with all these streams as you can have on the production. And then on the server side and all the tools, the switcher and so on, the support for 4K is already available. And we'll have, by the end of the year, the support of 4K over IP uncompressed as well on those products.
Phil, can you talk a little?
Yeah, so we've actually approached the product portfolio in a slightly different way, which is to detach the connectivity from the actual products themselves. So we put very much a focus on the tools being best in class. So, for example, like a Kahuna or Kula production switches, they should be the best production switcher in the market. Live touch for replay. Our multi-viewers should also, again, be able to support 3 gig UHD or even 12 gig in the future. From a connectivity perspective, we have a very similar view to Thomas, that in certain areas in the world, IP is not going to be adopted anytime soon. So we are seeing markets where 12 gig has got a lot of attraction. We're seeing customers that are taking existing infrastructure, which maybe was done for 3 gig for 3D in the past, and adding in 2 more lanes and just going for a quad environment. So we, from a product portfolio, we let you choose the production switcher, the multi-viewer, the replay server, and then you can either have a combination of 12 gig, 3 gig, or IP all at the same time, or you can choose what the configuration that you want. But we very much, in the IP domain, want to ride the curve of connectivity to make sure we give you the best connectivity to the device, to make sure you can fully utilize the device. And a great example of this is if you look at our production switcher, we have 120 inputs, but actually we can grab a lot of the streams and a lot of the signals upstream as if they were attached directly to the frame. So we don't need to grow the size of our frame in order to accommodate a UHD production. And this is quite important. And I think when you're looking at the control layer, we as an industry, we have failed if the operators have to start remembering multicast addresses and IP addresses. And as we were saying, that the interface should be really as simple as source destination to take. It should be easy for an operator to go to operate. It should also be very easy for an engineer to go and fault find the system, whether it's a network issue or whether it's a connectivity with the SFP, the LC fiber, the switch, or actually the edge devices themselves. It should be no more difficult than what they used to today. So we've really put a focus on the products, making sure that they are best in class, but then also putting an equal amount of importance in terms of the connectivities and really letting our customers choose what type of connectivity they want to have to the device.
Sure. Same question to you, Thomas?
Yeah, absolutely. Well, first of all, our intercom systems work nicely side by side with any 4K system. just kidding. But talking about our MediaNet, which is the decentralized network which does the video part in Riedel, that system we see very much as a migration technology, because we, on one hand, support all the traditional interfaces, and on the other hand, we work towards the future. And because it's a decentralized network, it is already offers so much of what an IP network is about. At the same time, with adding more and more IP interfaces, it is, in my mind, the ideal solution to migrate. So even if you today decide, well, I stay just SDI, then I can just add some boxes or swap some boxes later with the IP connectivity to come. There's one misperception in my mind on our product some people have, and they look at the MediaNet fiber and compare that with IP and say it's a proprietary solution, so it's not IP. Well, that's correct, but at the same time, that shouldn't be compared to the IP side of things. Basically, the fiber side of MediaNet should be compared with the backplane of a frame. Only that we don't put all our devices in one frame and have a backplane, but we have a decentralized backplane structure. So what you should look at is basically the IP connectivity, which is independent from our fiber structure, since we have both. And having both always means you have more flexibility, and that means you have the freedom to choose on a day-by-day basis what you want and how much IP you wanna use. And since it's well, someone who does an investment today, I always tell, well, if you can hold off for another couple of years, then just wait and you will see what is the standard, what do you need. But unfortunately, well, also fortunately for us here, there is a need of investments. And from that point of view, I want to make sure that my investment is safe. So if I can invest in something which I know it fits with the price of a traditional solution, it supports all my traditional work processes with plug-and-play SDIs and with everything I know and fits to my engineers. And at the same time, I know I can upgrade step by step towards the IP future, then in my mind, this can be an ideal scenario. That's basically how we see it and what we offer to the market.
And finally, Simon?
Okay. If I could answer that question in 3 parts, I think it'll give some indication of where we're seeing traction in the 4K as well. First part of that question is in replay systems, where we're seeing, particularly in North America, a lot of customers buying replay systems to support 4K operation, things like Sunday Night Football, Monday Night Football, ESPN. Along with that, other supporting equipment. We're also seeing a lot of the truck companies upgrade master clocks, adding 4K test patterns and capability like that to the equipment, which tells you they're actively working in the 4K environment. Then the middle one, part 2 of the answer, in fixed infrastructure in larger broadcasters, we're seeing a very rapid uptake of IP, and that's mainly to support future formats such as 4K and 8K. So we're seeing a lot of interest in IP systems, a lot of systems going in. And then I think the third part to the question, moving away from North America and Europe, we're seeing interest in 12G-SDI. So we're developing products like small routers, gearboxes, DAs, that kind of what I would call low-level supporting product. And that seems to be mainly for smaller OB, small to medium-sized OB trucks, where I think there's a recognition they don't have the skill set or don't want the skill set yet to work in a fully IP environment. So those 3 distinct areas are where we're seeing movement into 4K, and we're developing products actively for those markets.
Thank you. Andreas, do you have time for questions? Or?
Are there any questions from the audience? No. Then I will have a question. You already mentioned that talking about the transition to IP, it is crucial to have skilled staff in the production. And isn't it also crucial to have going IP and graphical overlooks, and for the user it has to be the same. There should be no difference in managing the systems. And probably you could enlighten on this, how crucial it is to have a system that feels the same for the user, whether it's SDI or IP.
I'll run with that first. We've made a conscious decision to split the system sort of across the middle, really, so that the engineering layer, which becomes IP, is very much transparent or hidden away from the operators, so that a traditional operator can sit in front of an IP-based system and just make source destination routes, for instance, and really have no need to know that what's going on under the bonnet is an IP network. So that's one way to solve the skills problem. The engineering staff obviously still need to know what's going on, but you keep the operational staff working in a conventional environment. The other thing we found it's essential to do is into the control systems, the traditional sort of router control systems, is to build in lots of diagnostics. So you can pick up a source, you can see which parts of the IP network that flows over. And that allows traditional broadcast engineers to have a much more sort of familiar feel to the system and be able to track which fibers a signal is flowing down at any one time. So I think there's two answers there.
Yeah, thank you. Someone else?
So just to add to that, where we're seeing the IP trucks come into the market, where you would historically have a VT guarantee for the truck, a lot of these people who are filling these roles today are being reskilled to become an IP guarantee. And it really depends on the type of COTS technology that you put inside the truck. The monitoring system is very key to the system, because the days of going in the back of a racks with the waveform is going to change. You're still going to need that skill, but again, it comes back to fault finding at SFP level, LC level, flow level, whether the flow is actually making it from the ingress to the egress point. And I think that actually the jump actually is not that big. I think you've got to have people who are willing to embrace change and run with it. And I think this is where we see the customers that are moving to IP, they actually have the capabilities inside the team. They just need to retrain them. And I think this is, as an industry, we have to support this effort moving forward, I think, if we really want to see this technology being embraced. But I totally agree. The technology from an operational perspective, they shouldn't really care whether it's SDI or IP, because there will be scenarios where you have a mixed environment, quite frankly, where you're going to have some SDI and some IP. The experience should be the same. And this is actually something we spend a lot of time in testing to make sure that we have the same level of performance as what you're used to today.
I think the question underlines what I said earlier. It really needs to be as easy as as managing the current infrastructure, and the same skill sets needs to do that. The real challenge there is the question about responsibility, because if one vendor sells a system now and is responsible for the end-to-end system, then this is manageable. But now I think of I buy network devices from one of the big players, and I add certain devices from like us. And now a signal going in, not coming out somewhere, who do I call? Because that's always the question which arrives. And I think as long as we don't have a clear answer to that, we do have a problem. Because obviously it's clear I can't call Arista or Cisco if I'm on a job expecting that they tell me where the signal gets lost in the network. And that is exactly the challenge. And if we talk about these services and the support, then I'm also asking who pays for that? And we can already see that in smaller systems, even on the comm side, where basically switches come into the game. And there is issues, and the issue might be with our devices, but it also might be somewhere in the switches. I mean, basically, we're all making mistakes, so it's not just exclusive to like vendors of us. There's also bugs in systems from whatever IT equipment vendor, and therefore, if I get the call and I do the troubleshooting on this and I help, and obviously we do because we feel a very strong responsibility for our clients, but at the end of the day, someone has to pay the bill for also the service things. That topic is not really addressed properly currently in the industry. There's a logic that basically you need service level agreements to cover this. But over the last 10 years, there were less and less service level agreements in the industry. So people are not used to spend money basically on a yearly basis for something they've invested. But I think this is an area we will get used to that again, because this is something I have to say in the evaluation of systems and looking at the total cost of ownership, we should look at that, because for current systems, not being IP, you typically don't need that. For an IP-based system, I can't see any way around a service level agreement to make sure that you can really call someone to get the right service.
Yeah. I wanted to complement a little bit on what Simon was saying, and also at the beginning of what you were saying, Thomas, is that the operator, it shouldn't change anything to him, and I believe everybody agrees that it's not his task to make sure that when he presses the button, what is supposed to happen happens. That's the job of the engineering team. And today you have these two teams. You have the operating team, and you have the engineering team. And probably there will be the need to have a third team, which will be the IT team, which will support the engineering team, who will make sure that, or give the tools to the engineering team to make sure that they can support the operating team on top of that. So maybe what we're getting to is that moving from one cable, one signal that you could easily monitor, plugging it into the waveform on any screen you have, bringing many streams on one cable will actually require another level of support and knowledge. And that's maybe also solving your case of saying, okay, no, I have support guys, engineering guys that do not cost the same as IT guys, but you don't need to bring as many ITs on the event as you need engineering team.
But you talk about big projects, because if I hear about team here, team there, then this is a big project. I'm talking about projects where you might have just one guy. You know, and that's exactly the point where I see it will be very difficult, because you know, that guy needs to cover all that knowledge, and that automatically tells that IP systems will come into very large installations earlier, because that's where I can afford to having my expert group. But in a small installation, also on a truck, I think that's where it will take longer to adapt the new technologies.
Obviously, but I don't think that the director is going to take care of all the colorimetry and all the setup and all the IT stuff. So you do have at least a few people, each one in charge of each part of the team. It doesn't have to be 100 people doing the production. Even if you have 3, you have that repartition. What I'm saying is that there's maybe an additional layer that will come under what we know today to support that.
But I think you make a good point, Thomas, is that actually today a lot of these large IP installations are large systems, because where the line is where it becomes very cost effective and actually becomes more attractive for IP is when you go above 500 square. And that's where we see a lot of these big projects are either large facilities or they're trucks. And actually in these cases you do tend to have the correct people. But you know, if we step back from it, the IT business actually has a very good way of managing SLAs. We just need to make sure if we're going to embrace this technology in our space, we also need to bring that across with us, because it is a technology shift in the industry.
Could I pick up on the point of cost of ownership? Because I think that's a very interesting point. As the industry moves more to using IT-based equipment, we're going to have to change our mindset. We're typically today used to equipment that might last 7, 10 years, big broadcast infrastructure. As we move into using IT equipment, 3 years, a server, a router, or whatever might be obsolete. You cannot get fans for it. You might not be able to get software updates for it. So you've got to look differently at the cost of ownership and be aware of what you're getting into when you buy into the whole IT sector. It works in a different way.
You think it's only 3 years?
For some, this is a question or an answer that was given by somebody at Google. They're large central switches. They replace after 3 years because they're internet facing and they have a security risk.
But on the other hand, it's definitely not 7 to 10. It's more like 10 to 15. Because if we look at the lifetime of broadcast equipment, how long it's really used, I mean, the typical time you write off the equipment in a truck, it's 7 years.
Yeah.
And in lots of markets, over these 7 years, the companies are not even making money. So they only start making money after the 7 years. And so they need the 10 to 15 years to really maintain their business model. So that's where I really struggle to see how this should work. And because then on the total cost of ownership over 15 years, you will have a multiple of investment compared to what the traditional technology is, and I can't see that, because the market does shrink. It doesn't grow.
No, but for
IT
this part, sorry, but for this part, if your equipment lasts half the time but costs half the price, you're at the same balance. For the IT part of the switch, and if your product stays the same duration at the same price.
Yes, but currently it's the other way around. But currently it's like the classical SDI equipment is much lower in price than an IP solution.
Yeah,
so now
right.
if I add that and multiply that, then I add up at a much higher cost.
Totally.
And that, in my mind, will not. I mean, it might work in a number of like pioneering projects where people just for the sake of IP want to do that, but it won't work in the whole market. How should it?
Yeah.
I mean, it's just logic.
And that's why I would like to quote one of my customers who once told me, if anybody tells me again that IP is cheaper, I'm going to punch him. At least today. I believe it's going to come there, but not today.
But I think there's different business models. So you can look at certain customers that buy the modular frame and leave it half empty, and they can expand with the different line cards with the different speeds. But actually, with a lot of the COTS vendors, they're offering technology refreshes. So as part of the total cost of ownership is actually you're not owning the switch. It gives you the option every 18 months, 24 months, whatever that period is, to switch out the technology to give you better density on port speeds or better connectivity that you need. I think it's just a different way of doing business. I think this is something that historically you have in the IT and the telecommunications area, but it's going to find its way, and it's really going to boil down to you need to really step back from, instead of owning the switch for the router for 7 years, you can just do a technology refresh, and if you don't need to change it, you don't change it. But if there are support SLA agreements that need to be maintained, it's likely they'll be attached to a technology refresh, which means that you'll be buying into a 24-month, 3-year period where you're actually going to swap out the technology. And most of the COTS vendors, Juniper, Cisco, and Arista, offer this today for a lot of their customers.
Yeah, okay. Thank you, gentlemen. If there are any questions in the audience, I'd like to thank you all. Very interesting discussion. And, well, I think we all deserve a little refreshment. We have ice cream out there, so get yourself some cups. And see you in a couple of minutes for the next discussion. Thank you very much.